So the sequence is that, as we already discussed, the sample is nebulized and enter into the plasma, and then after that it goes to. So these are the again basic things. I just keep it. The During analysis, the important aspects remain is a qualitative analysis and quantitative determination, like the what is the which metal and what is the concentration. So both the things comes in, which metal and what is the concentration of the particular, what is being getting analyzed and what is the concentration kind of thing. So how much it is. So this is the qualitative and quantitative determination. In the quantitative determination, whenever we measure the quantity of any element in any method, we need to standardize this particular instrument. Same in the spectrophotometer, same in the atomic AS, same in the ICP-OES, and same in the mass spectrophotometry. Same in the all the method. So quantitative analysis require the say the standardization of this one. Uh, so optical emission spectroscopy is a comparative technique. Obviously, so it compare in which the signals from the solution of known concentration is used to generate the calibration curve compared to the signals of the unknown sample. This is the same thing. We need to calibrate the instrument first, and we need to ask them like this particular concentration. Assume this particular concentration as a 1 mg per liter kind of thing. So this is a calibration curve we need to like generate in the all the techniques. The application of this ICP-OES or MS is to for the environmental analysis application. Yes, for the water samples, soil samples, petrochemical analysis, metallurgical analysis, geological analysis, like what is the concentration of different metals in the rock, food, and everywhere, whenever you want to measure the metal concentration. Prior to the then again, it's not something we collect the sample and we send it directly to the instrument, because instrument is sensitive, it has some limitation. So prior sending sample to for the analysis, we had at least we have some generic idea, like um, what is the what could be the probable metal in the sample, what could be the probable concentration, at least broader concentration kind of thing. So the some important criteria for the selection of the technique when we work on the ICP-OS or MS. So detection limits is the one of the criteria. Analytical working range, data quality, cost, interference. So when we go for the environmental sampling for the trace metal analysis, uh, actually the most important, or the I would say bottleneck of the environmental sample analysis, or the getting the accurate results of particular environmental sample is the is mostly depend on the how we perform the sampling, because sampling in the sampling we just collect the 1 liter of the sample out of entire lake or river. So it should be the representative of the actual condition in that particular lake, or in the particular river, or in the if it is the groundwater. So obviously it should be the representation. So there are various sampling procedures, standard protocols are there, been been laid by the various regulatory body. So we need to follow that sampling protocol um, uh, prior to collecting the sample. So sampling procedures, so I will not discuss here because it probably not of use, but I just like give the one example, like how the sampling would affect the why the sampling protocol is required. If I want to collect the water sample from the hand pump, for example, so if I directly fetch the water and the water comes first, I collect it as a sample. then it could not be the representation of what is the water quality of the bore well on which this hand pump is being attached. For that, I need to initially flush the 10 to 15 liter water, and so during that time, the water which is being say store remain store for the longer time on the pipe, this metal pipe will come out, and after that the actual groundwater sample will come out. So that's what I need to flush the 10-15 liters first, and after that I need to collect the water which could be the remain as the say the representation of the sample in of that particular borewell. So that is what I said. There is a various protocols. A sample preparation is again one of the the important aspects when we measure the sample. For the water sample, what we do when once we collect the water sample from the any place, from the surface water or groundwater, we initially filter this water sample through these small filter papers. In that case, these are the small polymer the filtration kit we carry to the field. It is of 25 micron. It has a pore size of 25 micron. So we initially pass the water sample through the injection through these filters, and after that we collect this water in the collecting like sampling bottle. What is the use of this syringe? Why we use this syringe and the filtration cap is that the water may be turbidity remain there in the water sample getting removed by the say caps or the filter papers in that case. So turbidity getting removed in the field itself, and after that we add some ultra pure nitric acid to the sample, like filtered sample. Why we add ultra pure nitric acid? Because we wanted to reduce down the pH of the water sample immediately below or around 2 to 3 pH, right? For that we use the ultra pure nitric acid. Why ultra pure nitric acid? Because if I use the general nitric acid or the nitric acid which is the air grade nitric acid, in that case if I use the air grade nitric acid for the reduction of the pH, then the water, maybe the metal content in that nitric acid, air grade nitric acid, is being carried to the my sample. That is what we use 99.99% pure nitric acid, so that it doesn't have it won't have any metal concentration, its own metal concentration. And the I would like to say that the cost of this ultra pure nitric acid is considerably high. We purchase it, so it is around 80,000 INR per liter around. So we need to use around zero point 0.2 mg, zero point 0.2 ml nitric acid for the say 50 around 50 ml of water. So the sample preparation is one of the great aspects or the important aspect in the environmental sample analysis. This is what we discuss. We need to again understand the TDS of the probable TDS. We need to analyze the TDS first. Why it is required? Because if it is too high, we need to dilute the sample to the distilled water in that case, or deionized water. We do not use the distilled water for the ICP-OS analysis. We use the deionized water, where we do not assume any conductivity or any metal from the metal contribution from the water. So these are the then as I said, we need to prepare the calibration curve. So we need to prepare the standards with the different concentrations. Say I wanted to prepare the calibration curve up to 100 mg per liter, for example, up to 100 ppm. So I need to prepare various standards, say from 1 ppm, 5 ppm, 10 ppm, 20, 50, and 100 ppm. So for that, I need to use the NIST certified standard reference materials. And by using this standard reference material, I need to prepare the various standard to generate this calibration curve. we discussed like water and chemicals, whatever maybe we use during the sample preparation should literally don't have any metal or the its own contamination. So that's what we need to use the say deionized water and the ultra pure nitric acid. So when we prepare the calibration curve, this is been very much important. So we need to understood the LOD. LOD is the limit of detection. Limit of detection means obviously for all metal instrument doesn't quantify the metal at the 0.0001 ppb or the ppm. So beyond the instrument's accuracy started beyond certain concentration. For example, in the arsenic, in the case of arsenic, you can't like ICP OES doesn't provide the precise results below 50 mg, below 50 ppb, right? So below 50 ppb, ICP OES do not provide precise results for the arsenic, right? So that is what the limit of detection is very much important. Like we're supposed to know what is the limit of detection for the each metal. See, for the copper, it would be different. For arsenic, it is as I said, it's a 50 ppb. Below 50 ppb, you won't get accurate result. And the you're supposed to know the limit of quantification and the limits of linearity. Then is a in that in this very simple language, limit of detection is the lower limit and limit of linearity is the higher limit. So we supposed our sample value supposed to be remain between the LOD and LOU. So these are very much important when we go for this. Actually, as I said, we are associated with the various judiciary related cases like High Court and the NGT cases. In that case, in for these particular projects or these samples, these things are very much important, and we need to follow the all the protocol. I would like to say you that. Discuss here. Would like to say that my lab is NBL accredited, so we has to maintain and understood all these things, the quality related aspects while analysis. Then again, important aspect is the wavelength selection. We need to select the appropriate wavelength because as we know, each metal had or non-metal have different wavelength, so we need to select the wavelength. And then the how to like how to rely on the results what you get. So for that, in the analysis terminology in the, or the analytical methods, we rely on two aspects like quality assurance and the quality control. So look like the same things, but these are the different aspects. But we need to follow. As I said, my lab is NABL accredited, so we need to assure the quality and we need to again control the quality, right? So quality assurance is a proactive approach of quality management which focus on the preventing the defect at the process level. QA is the process oriented. So my process should be a standard. If I so that is what that assure the quality, right? My sampling method should be standard. My sample preparation method should be standard. The sample transportation method should be standard. So these things assure the quality, like that is what the assurance. If our sampling method is itself wrong, then obviously it won't assure the quality, expected quality, right? So the quality assurance is the management approach. Actually, we supposed to have good environment where the instrument is kept. We supposed to have the trained manpower for that sake, right? So these are the assurance or the quality management aspects, and the quality control is a reactive approach for of the quality which work by finding the defect of the product itself. So many things comes in. I will discuss in. So QC is the product oriented, right? So the QA is the process oriented and the QC is the product oriented aspects. We'll discuss these things in little bit in the better way. And why this QC and QA required? Because if we have QA and QC process in place, our client would have the confidence that whatever may be result they are getting from our lab or instrument, these are accurate. So this is a um, trust issue actually in that case, or as a trust showing parameters. So quality assurance is the management tool. As I said, it is a process-oriented proactive approach. It is the proactive approach. It means that we are following these things prior happening anything, right? And it's a defect prevention, as it's a process-oriented. And the quality control is a product-oriented reactive approach and the defect detection. If there is any defect happens, so it is a and there are like 7 quality control like uh, tools. So in that case, so these are the check sheets, cause and effect diagram, Pareto chart. These are the things, probably histogram, control charts. So my lab has a histogram, control chart. These are the like different topics we'll discuss in, and these are the very important topics. And these things like control chart tell you how your instrument is going on, what is the health of your instruments. Okay. So in that case, I just don't spend more time on it. um, so quality assurance is it prevent error because you have all the procedure in place. So it won't prevent the error, it prevent the error. Even the doctor perform any operation, so there are some process you follow A B C D, so it has very limited chances of mistakes, right? And quality control is something, some mistake if happens, like, and then after that we need to detect that error, the mistake, and we need to correct it. So this is a quality control thing. Okay. So these are the various tools are there, like uncertainty measurement, calibration certificate, CRM, control charts, enable accreditation, and all these things. And the quality control is the duplicate triplicate sampling. So it will tell you like what is the results, what is the error and precision. Proficiency testing, I could send the one same sample to the 2 different laboratory and will compare, or 3 different laboratory and compare the results. So this is the proficiency testing. Inline online calibration means where we calibrate the instruments, and after that, in between, after 5 samples, we again run the standard. Again, after 5 samples, we again run the standard of different concentration. We check the concentration of the standard as a sample. Then it's inline online calibration, we can say. Ionic balance is a very good tool, I will tell you. For example, if you give me the concentration of calcium, magnesium, sodium, potassium, and or calcium, magnesium, and as a cation, and as an anion, you just provide me the concentration of sulfate, phosphate, nitrate, chloride. So I can calculate the concentration of sodium and potassium by using this ionic balance tool. So these are the various tools are there to check the results which you are sending out of laboratory are the true, are the accurate or not. So when we analyze, there are various interference. Obviously, there are physical, chemical, and spectral interference, different kind of things. We'll discuss little bit. Physical interference is because of viscosity in the sample, high dissolved solids, acid type, as I already discussed, the surface tension, organic solvents if they're in their sample. So there are various methods to solve this physical interference, like dilution, matrix matching, internal standard use. Um, so these are the various methods. Inline online calibration also gives, as I said, how we perform the inline online calibration. So the sample 1, 2, 3, we run these samples. After that, we run the standard, say, of 1 ppm. We check the results of the instrument. So it will. We know that the standard which been spike is having 1.5 mg per liter as the concentration. We check the results of the instrument, and likewise we know we repeat the thing after 4 or 5 samples or every 3 samples. So these are the internal standards. Uh, is again the second methods to check the accuracy. What is the internal standard? Internal standard is the we are going to add the known concentration of any metal in the sample itself. So we know that we added the 5 mg calcium, or sorry, 5 mg copper in the sample. So we check the concentration of copper along with the other metal ions in the results. So we know the copper we added is a 5 mg per liter. Then what is the instrument? What the instrument is showing? So likewise, we this is the internal standard mixing. Internal standard we use. Chemical interferences are there. Obviously, it's because of say overlapping of say um, say in that case spectral interferences are the chemical which are used in the standards or during the sample preparations. These are again add some interferences. This is what I said, the spectral interference. Uh, for example, this red one is having it is been getting interferes. You will get this red if it is in 249. So you get the barium get interference with the thorium. It get because thorium is also having the emission spectra at the uh, same wavelength, so kind of interference will be comes in. So you need to select the special type of the or the different wavelength for the different metal. Okay. Spectral interference are there because of the plasma, solon base, isobaric, and all these things are so these are the very specific for the instrument operator. Wavelength selection is important, as I said. This is because of the interferences. This is again important. Uh, there are the various factors which finally affect the accuracy of the results, which include the container where we are going to collect the sample. If container itself is contaminated or it has something inside, it's stuck inside, so it will contribute to the error. Environmental are there because there is protocol for the transportation of the standard metal samples. Standards could contribute if our standards is being contaminated, or we do not prepare the samples as per the standards as per requirement. Method, what is the again the person specific, like what is the like proficiency of the person, collection of sample reagents, and all these are the things which will hamper the accuracy of the results. This is what the few calibration curves. So these are the calibration curves from our samples. For example, for the iron, we had the calibration curve. For the iron, we select this 238.2 as a intensity, right? Wavelength in that case. So we prepare the samples at the different concentration from say 0.5, 1, 5, 10, and then 20. We had run these standards to the instruments, and we had calibration curve. We'll check the accuracy, R square, and all these things. For example, for the zinc, accuracy somewhere get mm, say departed. So we had, if you can check the zinc concentration at 5 and 10, it seems to be linear, but for the 20 it goes down. Probably there are various reasons for this going down, right? And it directly affect the accuracy. R square is a 0.9942, it's a 99.42%. So in case of Fe, it's a 99.9%, right? So this is because the standard which is prepared for the 20 ppm is not accurate, right? So this is what again the one of the perfect standardization graph for the vanadium. So it is 99.99% accuracy, right? So this because the all the standards which are prepared are the accurate, or the preparation method is accurate, right? Uh, this is one of the calibration curve for the for one of the metal like Hg. This is for the Hg. You can see the error itself, like how the standards has been prepared. They are not accurate actually. Standards are not accurately prepared. So you can check the all the things, right? So this can be so instrument provide such kind of results to us, like calibration standard one, and the net intensity we will get, and the accordingly we get the concentration. And this is what the results we get. This is the all the results for the standards we prepare for the. Actually, here I would just like to say that we get the standard SRM, in that case certified reference material, or the standards of mixed standard, in that case of 9 metal and 23 metal. So in the same bottle, we will get 9 metal in the equal concentration. For example, if I use the bottle of 9 metal solution, there it has 9 metal with the same concentration, right? So here and one more concentration comes in the market is a 23, again 16 come, right? So so here we have prepared the the like standard with the zero point 0.5 mg per liter, and these are the results, like standard concentration in the third column. We can say the we prepared zero point 0.5 ppm standard, and this is what the response of the instrument to the all metals, right? So all metals. So in case of say iron, so we'll get 550 ppm. So we prepared the sample of the standard concentration is zero point 0.5, but we get different concentration for the different metals. Again, this is for the 1 ppm, so we get different results for the different metals. This has been majorly been contributed by the interference, and all these things affect the concentration, right? So the concentration, because this is only one sample we run, and we get different concentration for the different metal. This is because various interferences occurs, like wavelength interference on all these things comes in, and we get different results for the different metals. This is what the why we do all the things, right? What is the important, like why what is all these things required? Because this is what just think of this shaded one is our area of interest, or the industry boundary, or the industry area. And I just wanted to understood the effect of this industry on the nearby, or the effect of this industry on the groundwater, on the groundwater sources. So what is the pollution being contributed by this particular industry? So the first step is to understood the product line of this industry, right? What kind of metal it can be generate, what is the product, what is the say input product, raw material inputs, what is the product, what could be the probable constant metal in the wastewater. And from there we come to understand, like this metal could be, or these organics could be contributed by this industry to the nearby environment, like. So after knowing the product line, after getting through the product line, we target few metals, few parameters, and then after that we studies these metals in the nearby area. This is what the 5 kilometer area from the boundary of this particular industry, right? So we collect the sample from the entire area, 5 kilometer area. We understood the topography. This is what the watershed basis. On the watershed basis means from where the water flow, from which direction to which direction water flow, what are the different rivers or the nala in the particular area, what could be the direction of the water flow and all these things, natural water flow. And then after that we calculate the what is the probable direction of the groundwater flow. We can measure these things by using various techniques. We measure it generally regularly. So after that we quantify the understood the entire geology of the area. So what is the stone type, what kind of rocks are there in the particular area, and then it will help us to understood the contamination or the environmental say damage been contributed by this particular industry. For example, these are the results for the different metals in the particular area in the pre-monsoon and in the post-monsoon area, and it will tell us what is the concentration of different metal in the particular area. So, so there are various things so we come to understood, and after that we can conclude that this has been after getting all the this metal is one of the example. Obviously metal won't say all the things. We measure all various parameters actually. So finally we come to understand like this is being this metal has been contributed by the industry or not, or whatever may be, and if it is there then what is the quantity and what could be the remedial actions for that to further damage the environment, right? So this is what the use of ICP OES or ICP MS in our work. We routinely do it in my lab. Around like 3 to 5 thousand water samples per year being getting analyzed. I had water quality. I am a manager of water quality testing laboratory. So around 3 to 5 thousand water samples is being tested in my laboratory, and obviously equivalent amount of metal samples. Like we send these metal sample to the our sophisticated analytical facility for the metal concentration. Right. These all the project. These all the samples related to various projects in the department. So so the conclusion thing is that ICP, OES, and MS are considered to be the most advanced level and rapid analytical technique. It hardly take like 5 minutes for the one samples to get the results, and the both the techniques are the reliable, and you can choose the technique based on your metal concentration, expected metal concentration, and if you require the ppb or the downside concentration measurement, you go for the MS, and if you require the ppb kind of measurement, then go for the ICP-OES. And that is what the basic understanding you should have when you choose the method for the analysis. So this is what the from my side we'll discuss. If someone is having any issue, some question, sorry. So I just stop sharing my screen.
Yeah, Atul sir.
Yeah. Yes, sir.
Sir, actually, if we want to characterize our samples in your center, is it possible? What about the charge of the per sample?
Actually, we follow the CPCP guideline, Central Pollution Control Board guideline. Central Pollution Board (CPCB) has finalized rates for the different rate for the different metals. So they, if you can search it in Google, like CPCB water quality analysis charges. So you will come to understand like what is the charges. The thing is that you have to send an email to us, and that is enough.
So, how many days?
Actually, as I said, the analysis hardly required 5 minutes. And for the metal analysis, I don't think so. If everything is fine, I don't think so. It will take more than 3 4 days. If even the instrument is busy, obviously 3 4 days is more than enough. because in a day you can process like 100, 200, 300 samples. That is not issue. And again, the instrument comes with the auto sampler. You just need to put the samples and it will automatically collect the samples and analyze.
So we just post from here. Actually, I am in Jaunpur, UP. So
Mhm.
just post the samples in your center, in your institute.
You are in
So
UP, then I would suggest to contact to the our different lab at the Lucknow.
okay,
Lucknow, you have two lab. Um,
okay, in Lucknow, in CDRI.
yes, CBRI. CBRI is actively involved in the analysis.
Okay, okay, sir.
So all CSR laboratory has analytical facility and it's open to everyone. You have CDRI, you have CBRI at the Lucknow. Two lab we had at Lucknow. It will be if you directly travel to the laboratory is well and good, and it will save your travel cost or
Yeah, yeah.
logistics.
Here we can travel, sir. It's a 5 to 6 hours by bus.
Sir, you are
Uh,
working in which department?
Actually, sir, Department of Chemistry and my major area is biopolymer nanocomposites.
Okay.
So sometimes it's a we checking the our membrane. It's after food packaging covering. It's leaching is there or what elements from the films is going to mix with the food. So
Yes,
sometimes
you need to
uh,
measure the leachability study. You need to go for the leachability study. Yes,
right, right, sir, that one.
right, right.
Okay, sir. Thank you. Very nice lecture, sir. Thank you.
Thank you, sir.
Hello, sir.
Hello,
Yes,
sir.
sir.
Yes, sir. Sir, very nice lecture, sir. I just wanted to ask, sir, is there any pre-treatment for a sample before the analysis with respect to ICP, MS, or ICP OES?
Sir,
Any
pre-treatment
pre-treatment?
is once you collect the sample, immediately you need to filter it out so that the external impurities should be get out. And
Okay,
after that, we need to add the ultra pure nitric acid to the sample. Okay. The why we add ultra pure nitric acid or why we reduce down the pH, because in the if we consider the water is having neutral pH, say 7 around, so there is a chances of oxidation of various metals soluble in the water, and this oxidation leads to the say it gets settled down at the bottom as a hydroxide, right? For example, iron, if we had the iron in the water, so after some time the iron flock gets settled down, iron get oxidized and get settled down, so we'll get inaccurate results, right? So that is what we need to immediately reduce down the pH of the water sample to around 2 to 3, so that the further oxidation won't take place and it won't get settled down at the bottom. And there is some second thought, like even the pH of the water sample is 7, then why won't it get settled down in the water sources itself? Because
uh,
because if we fetch the water from the ground, there you know that anaerobic condition is there, and it won't allow oxidation of the things in the water,
okay.
even if even it has a pH 7, right? So what once it come on the ground at the surface, there is chances of say oxidation.
Oxidation. So, sir, sir, it is possible to use the lab grade HNO3? Is there any
No,
possible of
sir, no.
impurity?
Sir,
Okay, okay.
in that case, the lab grade nitric acid would add some impurity, but we
Okay.
can, if our the concentration of interest is beyond ppm, like 10 ppm, 20 ppm, then it won't affect the results that much. For that, we need to run the say distilled
Blend,
water
blend.
with your say
That lab grade HNO3.
lab grade HNO3 or the
Okay.
acid, so that we can correct this noise in that case as a from the solvent itself.
Okay, okay. Thank you, sir. Thank you.
Hello, sir.
Yes, sir.
Hello.
Yeah.
Thank you, sir. Thank you very much for your nice presentation. I just have one question regarding a research point of view. Um are the qualitative as well as quantitative analysis of this metal in different samples? Why the electrochemical techniques are not employed or as regards the commercial point of view? In any research institute, because although number of papers research is going on in that field showing very much sensitivity as well as the techniques are very cheap, but they are not employed at the commercial level. Only everywhere atomic absorption spectroscopy used. Why not those electrochemical techniques? So many electrochemical techniques like voltammetry, etc. They are there. Why not they are employed?
Sir, we can employ this technique, but the thing comes in, like if we want to use any technique, the capex of the instrument is the first aspect, then operation maintenance, and because the keeping the instrument live for around say 20 years is a challenge. It's a challenge, real challenge, in both the sense like manpower and the cost, and again the consumables you require for the day-to-day life, day-to-day operation. So the cost is the basic things, happens everywhere. I worked in industry and I mean CSR lab from last 14 years. So cost is a basic thing actually to which limits the thing. Why ICP OES or MS? Here in ICP OES or MS, the consumables are comparably say cheaper, or the operation maintenance cost would be less, and you do not require very skilled manpower. So MS required some time, but the ICP OES do not require that much skilled manpower. So that is what the and the again so many things comes in like reliability, the instrument damage and all these things, and again so people knowledge or awareness, these things comes actually.
As regards the you were saying maintenance and cost, the electrochemical techs are very much cheap compared to these sophisticated techniques like atomic absorption and all that. But I don't know why they are not commercialized, because everywhere we see atomic absorption spectroscopy. I have also my own research in their field, electrochemical sensor, right? But it's very difficult to get that instrumentation in any institution, in the research laboratory in India. Although in outside, lot of institutions are there where these techniques are employed.
So again, actually, the thing is that availability of the instruments and the these things comes, and if you are aware that somewhere UGC the like commission in between had an idea to have one sophisticated instrumentation facility at each university campus, and it was been established almost all university, as I know, say 20 years, 20 25 years back. If I'm in Nagpur right now, so I know the situation. What is there? What is the situation of this particular center at Nagpur University? It is remain closed because the whenever that particular program has been planned, they had budget for the capex, but they do not allow any budget for the ONM, operation maintenance, and that's what most of the instrument in most of the centers are remain idle, or no one is using these instruments. And now after once you don't use that instrument or any instrument for 1 year, it will be remains like ideal, and you need to go for the again so servicing and all these things, and it won't work. So it was actually planned in India, say 20 25 year back, but anyway, like people change and the criteria changes, and the things doesn't work after that. So this is what happened. There could be various limitations also. Manpower is again you required, if you, even though if you wanted to run the ICP-MS, if small things happens, you require the skill manpower there to check the routine issues. And even though I will just share one my experience. This each and every state has a state water quality testing laboratory. They had district water quality testing laboratory at all the districts places, and this comes under the water supply department of a particular like each state. And there is one state laboratory remain in one state, like you have state water quality testing laboratory at Lucknow, at Bhubaneswar, kind of thing. So we have seen, I personally visit to one state laboratory, and I operate the very sophisticated ICP MS there, and I particularly work there for 5 days, and we make it operational because the state laboratory again don't have any manpower. So I'm talking about the state laboratory. I'm not talking about the district laboratory or the university. So this is what they happen because you don't have that particular manpower, then it remain as ideal, and it won't work after some time. So that's the limitation actually.
Thank you very much. Thank you, sir.
Sir, can we test radioactive material present in the sample by this technique?
Sorry, sir.
Sir, can we detect a radioactive substance present in the sample by this technique?
Radiant.
Radioactive.
Radioactive are up to certain limits, sir. But after that, we go for some specific test. Radioactive up to certain limits, yes, we can check.
Okay, sir. Okay, sir.
Yes, any more questions? Participants, if there are no more questions, then we can conclude with the consent of our expert.
Okay, thank you. Thank you very much.
Sir, shall we conclude? Professor Atul sir, if
Thank you, sir.
Please, sir, please.
Yeah. So now may I request Dr. Mahesh Muluk sir to please propose vote of thanks. Please, sir.
Good evening to everyone present here. Myself, Dr. Mahesh Muluk, working as assistant professor in Department of Chemistry, Sri Pundlik Maharaj Mahavidyalaya, Nandura Railway, District Buldhana. On the behalf of the organizing team, it is my privilege to propose the vote of thanks for these enlightening sessions. First and foremost, I extend our deepest gratitude to our esteemed guest speaker, Dr. Atul Maldure sir, for taking time out for their busy schedule to share such a valuable insights with us. Your thoughts on the global standards for water quality monitoring lecture. I also express our sincere thanks to our program coordinator, Dr. Manisha Kodape madam. Thank you for organizing this lecture. We also thank you, sir, and the technical support team, MMTTC Amravati. Finally, I thank you, wonderful audience, for your presence and active engagement today. Thank you all, and a wonderful evening ahead. Thank you. Thank you so much.
Thank you, sir. Thank you, Professor Maldure sir, for such a wonderful session. And with the kind consent of Professor Maldure sir, I would like to declare that this particular session will be over here. Thank you so much, sir. Thank you so much for your precious time.
Thank you, sir. Thank you for patience hearing. Yeah, thank you.
Okay, so participants, we will stop now here. And as usual, tomorrow there will be a Sunday. So there will be a holiday tomorrow. And a gentle reminder for all the participants, our MCQ test will be live from 5:30. So all the instructions, I think we have percolated yesterday also. And right now I have put up the message in the WhatsApp group also. So I will request all the participants to kindly do the needful at their own. And my best wishes for your MCQ test. Thank you, everyone. We will stop now here. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir.
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 Thank you.